My name is Luke. I'm Matt, and today we're going to be talking about a little more complex systems with op amps. Alright, back on the kitchen counter. Got a new camera, so we're actually shooting in 4K. Today we're going to be talking about op amps, and what this is basically used for is it's actually a voltage amplifier. We touched base on this a little bit last week with equivalent resistors. So there's two different types of op amps. The first one is going to be an inverting op amp. What we have up top is this is our feedback resistor, and this is going to be our input resistor. To measure the gain on an inverting op amp, all it actually is RF over Rin. So let's say RF was equal to 10 k ohms, and our input resistor is equal to 1 k ohms. Let's say our input voltage was 1 volt, 1 k ohm, so we'd have a gain of 10. This would be equal to 10 volts on our output right here. So the second type of op amp is a non-inverting op amp, and there's a key difference between these two. So the main difference between our non-inverting op amp and our inverting op amp is inverting op amp produces an output which is actually out of phase with the input, which we're actually going to talk about later on an oscilloscope, whereas the inverting is just a ratio between the two resistors across the op amp. So our gain is actually going to be equal to RF over Ri, and we're actually going to add 1 to this. Like I said, we'll explain this a little bit later with our oscilloscope demonstration. But here's a basic understanding of op amps. So again, if we wanted to calculate the gain with the same type of resistors up top here, we would find that, and again, we'll do our Vin is 1 volt. Now, here's another important thing is look at where the power supplies are hooked up. For our inverting, the power supply is actually hooked up to the negative input on the op amp. And for our non-inverting, the input voltage is hooked up to the positive input of the op amp. So we would actually find that our V out would actually be equal to 11 volts as opposed to 10. The last thing that I want to talk about is what's called a follower op amp. Now here is where the magic happens. If this was a regular non-inverting op amp, we would have our feedback resistor up here, but what a follower does is it's actually just connected like so, and there's no resistance up here. What this will actually do is it'll actually amplify the current across the op amp. A lot of times this is used for when you have a really weak battery. Basically what the glory of this guy is our input voltage follows the output voltage. It'll keep the circuit from drawing too much power into it and making the circuit fail. Okay, so here we have a basic op amp circuit in LT Spice. These positive and negative 15s are actually what's powering the op amp, which is going to be able to give us our gain. If we were to do the math, we'd find that our gain would be our feedback resistor, which is R1, over our input resistor, which is R2. So in this op amp, we're going to get a gain of 10 volt. V1 is going to be equal to 1 volt. If we were to take a measurement from our output, we would find that it's 9.9998522 volts. This LT Spice circuit down here, I ended up building a follower circuit. What I actually ended up doing is, imagine this being a wire all the way through. I had to put this small resistor in here to be able to measure the current because LT Spice won't let me just click on it by itself. But if we actually run this guy, the input going across our input resistor is actually going to be 1.8 picoamps. When I click on the output for the current after our follower circuit, look at that amplification as far as graphs go. So we're basically going from 1.8 picoamps all the way up to 28.2. Okay, so this picture is really important. And what it actually shows is the grounding system that we're using. Now along the bottom, we see going from left to right that our far left is actually our negative 15 input, and then the two middle black wires are actually going to be a common ground. And the red wire all the way to the right is going to be our positive 15. What you're seeing in this image is a picture of our circuit, and the black square in the middle is actually our op amp. What that's able to do is magnify the input of the voltage coming through the red alligator clip in the top right, which is our voltage in, and then the alligator clip that's straight down connected to the orange wire is actually our output voltage. The brown resistor in the middle of the circuit is actually our feedback resistor, which was 10K, and then our blue resistor to the right is a 1K, so we have it set up exactly like our pen and paper example. We have the same grounding system as we did last week with the common ground between the two, positive 15 and our negative 15 respectively. We have our constant 5 volts coming in and then being amplified. Now the issue with what we're doing right now is we have a 10K ohm resistor and a 1K ohm resistor, and to find the gain we would just do 10 over 1. We're finding a gain of 10. Now if we have 5 volts coming in multiplied by 10, that would give us 50 volts, and that's going to be way higher than this 15 that we're putting as our control voltage. So what we're actually doing is we're saturating the op amp, and the max that we can get is negative 12.5 volts. So we have something kind of cool going on with our function generator. Channel 2 is actually hooked up directly to our function generator, and then channel 1 is actually going to be hooked up in our circuit with alligator clips. We find that channel 2 is the smaller wave down here, and channel 1 is 10 times larger, and when we actually measured that across the circuit with the DMM, we found our gain was about 10.
Alright, so here we have 9 volts coming in, going through a 200K resistor. This resistance is so big, there's so little current that it's not enough to power this LED.
So now that we're powering a chipset and running what's called a follower circuit, what we can actually see is when we increase the voltage, it'll increase our current enough over that 200K ohm resistor to be able to power on a small LED. Okay, so that was a little explanation about op amps. We really hope you enjoyed the video, and feel free to check back next week for more awesome stuff.